let's start off by looking at how a perfectly competitive firm operates. So, a couple of unique things about the perfectly competitive firm. They're the only industry where we have two different demand curves. If we look at the supply and demand curve for the perfectly competitive firm, what happens to the overall market affects what happens to the individual firm. Okay? Remember that in a perfectly competitive firm, one good is exactly like another. So when we look at the overall market, that's going to have a direct effect on each individual firms. So let's say if we look at the price and quantity of rice, a very homogeneous good, and we see that there's a downward sloping demand for rice and the upward sloping supply for rice, and let's say that we see that these two intersect at $5 a pound. Okay, $5 a pound, and there's some quantity in the overall market that's going to be bought and sold. That means that no individual firm can price their good or service anything higher than $5. If they price it higher than $5, the demanders will just go to a different firm because this is the market price. So nothing can be priced higher than that. A perfectly competitive firm can price it lower than that. They could price it at $4, but if they did that, then everybody else in the perfectly competitive market, all the other rice producers or the retail rice sellers would have to lower their price. So then everybody would be made worse off. So the demand curve for the perfectly competitive firm is going to be a horizontal line that is pegged at the same price as the overall market demand. Since no individual firm gets to choose how much they're selling their output for, all they can do is decide what quantity they want to sell. So let's look at a couple different options for what quantity they might want to sell. Let me get my pen a little darker for you guys though. Okay, so if we were to look at a perfectly competitive firm, they always want to maximize their profit. Every firm wants to maximize their profit. So if we remember from our reading, profits, it's usually written as pi, profits are always going to be equal to total cost, the amount of money that the firm has to spend, minus total revenue. Now their total revenue, total cost is all of their costs added up, but their total revenue is price that they're selling their unit for times quantity, the number of units being sold. Okay, so they can't choose the price that they're selling their unit at, so they need to decide what quantity they're going to sell. If we look at perfectly competitive firms, they all have a lot of general slopes that stay the same, just as we learned from the cost curves. So let's say that we are looking at a perfectly competitive firm, and let's say that we know that the price is going to be $5 a unit. Okay, so what is the total revenue curve going to be look like? Well, if they sell, let's say 50, let's just do a smaller scale. If a firm sells 5 units, and we know that the price is always going to be $5, then 5 times $5 would be $25. Okay, so that would be 1 point on our curve. If they were to sell 10 units, 10 times $5 would be $50. So the curve for the total revenue for a perfectly competitive firm is, of course I can't do this on this little tablet, but it's always going to be a 45-degree line. So that's going to be my total revenue curve. Okay, so $50 at 10. If they sold 20, it would be $100. Okay, so the total revenue, so $15, 15, 20. Okay, this would be somewhere around 100. Okay, so now I've got my total revenue scale set up roughly. So now I'm going to add in my total cost curves. I don't know anything about the costs for this particular curve, or for this particular company, but I do know that most of the time, if they haven't sold it, let's say if they sell only one unit, their revenue that they would be bringing in for selling one unit would be $5. But would their costs be higher or lower than that $5? Well, most likely their costs are going to start off higher than their revenue. And assuming that this firm makes some profits, at some point their costs are going to be lower than their revenues. And most likely their costs are going to increase as they make more output. So we're going to say that they're probably going to have some sort of curve that looks like that for total cost. That's a pretty decent total cost curve. So over here, they have what we call negative profits, okay? Because their total cost is higher than their total revenue. Up here, we have the same thing. Total costs are higher than total revenue. So that means that the only area that we see that we have, let me change color over here. Okay, so that means that the only area that we see where we have positive profits is going to be this interesting little parabola right here. At this point, right there, profits are exactly zero. Okay, because our total revenue is exactly equal to our total cost. The same thing happens over here. So when total revenue is above total cost, this whole region through here is positive profits. So if we were looking at this, remember that we always read the quantity vertically. So at 10 units, this is the amount of profits that they are making, the distance between those two curves. At 15 units, this is the amount of profits that they are making, the distance between those curves. Okay. So if we wanted to, we would say, well, the largest profits are probably right here. That went a little bit sideways, but the largest profits are probably right there. Okay, so let's say that that happens to be at 12 units or 11 units. Let's say that it's at 13 units. Okay, so that means that this firm is going to produce 13 units of output. This is their profit max Q star. Okay, that means that they're not going to pay attention to anything below 13 units or above 13 units. In order to profit maximize, we don't know what the firm's profits are going to be right now, but we know that their profits are going to be highest at 13 units. Okay, so once we move from the firm determining how much they're going to produce based on total revenue and total cost, we could also look at this exact same thing looking at marginal revenue versus marginal cost. So this is how a firm chooses the profit max Q star based on total revenue, and so that's an and sign, not an addition sign, total revenue and total cost. Okay, so now let's go ahead and look at this same thing, but instead of looking at it as total revenue and total cost, let's look at it as marginal revenue and marginal cost. So we want to find the same thing. We want to find the profit max Q star based, instead of on total revenue, we're going to look at what's called marginal revenue and marginal cost. Now, marginal cost we already covered. We know that marginal cost is the change in total cost divided by the change in quantity. Now, marginal revenue is simply the change in total revenue divided by the change in quantity. So let's think about marginal revenue for a second. We know that for a perfectly competitive firm, the total revenue curve is going to be a line that looks like that, okay? So this is going to be our price, and this is going to be our quantity. So what is the marginal revenue going to look like? Well, here we knew that if it was 5 units of output, that the cost would be $25. And if we go up to 6 units of output, the cost is going to be $30. Okay, if we go up to 7 units of output based on our $5 cost of a bag of rice or a pound of rice, $7, it's going to be $35. So that's the change in total revenue, or that's the graph of total revenue. So the marginal revenue looks at, well, how much is total revenue changing by when we add one additional unit? Well, total revenue, price times quantity, and marginal revenue, the change in total revenue divided by the change in quantity, is always going to be equal to the price because that's how much it's changing by. So for a perfectly competitive firm, this isn't true of all the other markets, but for a perfectly competitive firm, our marginal curve is going to be pegged at the price of the pound of rice. So this is price and this is quantity. So it's got to be $5. Okay, so that means that the demand curve is also going to be exactly equal to the marginal revenue curve. Now, from our earlier videos, we learned that the marginal cost curve always has kind of the same basic overall slope. And I said to try and remember that it's going to be what we call a Nike swish. So let's say that in this example, I'm going to say that the marginal cost looks something like that. Okay. Curves are really hard to do on this little tablet. Okay, so the marginal cost curve looks something like that. Now let's see what's going on at these points of intersection. At these points of intersection, the marginal cost and the marginal revenue are the exact same. That means that the amount that they're spending per unit is the same as the amount that they're getting back. So initially, we might think that that would be a bad thing. But instead of focusing on that, we'll come back to those 2 points. But let's look at 2 other random points. Over here, let me change the color so that we can compare these a little easier. Let's look at this yellow line where, the marginal cost is less than the marginal revenue. And then let's look at maybe this pink line where the marginal cost is greater than the marginal revenue. Okay, so let's say that this represents 5 units of output and this represents 20 units of output. So if the marginal cost is greater than the marginal revenue, we can pretty quickly say that's an area that we don't want to be in. We don't want the firm to spend more per unit than what they're getting back. So if we look at where they're getting back more over here in this area, in the yellow area, the marginal cost, I'll grab a yellow, the marginal cost over here is less than the marginal revenue. In the pink area, the marginal revenue is greater than the marginal cost. Okay, so that over this area, the firm is losing money. Okay, so we don't want to be in the marginal, where marginal revenue is equal to the marginal cost. So it seems like we would want to be where the marginal cost is less than the marginal revenue, or the marginal revenue is greater than the marginal cost. But now let's think about it. We know that we don't want to produce past this point. Okay, we don't want to produce past this point. We don't even want to go 1 unit where the marginal revenue is less than the marginal cost. So we definitely would be happy making 5 units, or we definitely would choose to make 5 units. Would we choose to make that 6th unit, that 7th unit, that 8th unit? Would we choose to make that? Well, the marginal revenue is still greater than the marginal cost, so yeah, we would make that unit. We're still gaining profits if we make that unit. Would we choose to make the 10th unit? Well, per unit, it's not as much coming in for profits, but we would still choose to do that. So would we make the 11th unit or the 12th unit? We would make the 12th unit. Would we make the 13th unit? Well, at the 13th unit, the marginal cost is exactly equal to the marginal revenue. Okay, so at the 13th unit right here, where these two come together, that point, marginal cost is equal to marginal revenue. Well, if we make one unit less, then that's basically that we're leaving money on the table. Okay, we're not getting as high of profits as we could. If we make one more unit past 13, it's going to start taking profits away from us. So this right here is going to be our Profit Max Q star. Profit Max Q star is found while making sure that the marginal cost is exactly equal to the marginal revenue. So basically we can look at our we can find the output that the firm is going to create in two different ways. We can look at where our total revenue and total cost are the furthest distance away, assuming that we know that our total revenue has to be larger than our total cost. Or we could look at it as, oops, I have too many open right now. There we go. We can look at it marginal revenue and marginal cost, and we can say that if the marginal cost is exactly equal to the marginal revenue, the firm can't be made any better off. So that's where they're going to choose to profit maximize. Okay, so after this, let's go ahead and look at a couple of the other graphs. We're going to take those average cost curves that we learned about in the last videos, and we're going to apply them to a perfectly competitive firm.